Logical functions allow us to test a true statement against two or more values. And so in its most basic form, we can just simply equate values and use comparison operators to test the equality. And so the resulting value either returns true or false if the comparison is true or false. So for example, if you had a function equals 86 is greater than 70, what would that return? It's true, so it would return the word true. We can also use logical functions to test value expressions. This is something we use a lot in data analysis, in which we use conditional operators to test whether a value is true or false, and then it returns a specified value for the first true value. So instead of the words true or false, it returns the value we want. So in the expression equals if, open parentheses, 86 is greater than 70, which it is, then comma, return the true value, which is pass, or return the false value with this fail. In this case, 86 is greater than 70, so the return value is going to be pass. We can also combine value expressions by using Boolean operators and utilize those to test whether a set of values are true or false. In the last bullet on the slide, you can see that we're utilizing the if function and the Boolean operator to test multiple expressions. In this case, 86 is greater than 70 or 68 is greater than 70. And if either of those are true, then the value returned is pass. If both of them are not true, then the value returned is fail. In this case, 86 is greater than 70, even though 68 is not greater than 70, and so it returns pass. So here we can see examples of logical functions applied in a spreadsheet. On the upper left-hand side, you can see the values, and on the lower right-hand side, you can see the underlying functions. In column D, we use the comparison operator. So basically what we're trying to do is take the midterm and final grades for these 4 students and utilize logical operators to come up with their grade. So first thing I want to do is if they passed or failed the final. So I use the logical operator equals the values in column C are greater than 70. And so it looks at all of the test scores for the final, and if it's greater than 70, then it returns true. And so you can see that Jane gets true, Mike got a 68, so it's false, Sue got 100, so it's true, and Frank got a 65, so it's false. We can also use the conditional operator in this case to identify the highest score. We want to know what their highest score was either between their midterm and their final. And so the function that is shown in the spreadsheet on the lower right-hand side of your screen is equals if, open parentheses, the values in column C are greater than the values in column B, then show me the value in column C. If it's not, if it's false, show me the value in column B. So basically, I'm just trying to identify the highest score. So if we look at E2 or Jane, for example, it'll compare 82 to 86, and if 82 is greater than 86, then the resulting value it's going to show me is going to be 82. In this case, it's not, so it shows me 86, and that repeats for all of the students. In column F, we're using the if function and the or Boolean, and then we're evaluating in column D whether they passed or failed the final, or if their highest score was greater than 70. And so if either of those evaluate as true, the student passes. If they both evaluate as false, the student fails. And so if you look at the resulting values in column F in the upper left-hand spreadsheet, you can see that Jane passes, Mike passes, even though he didn't pass the final, it was false. His highest score was greater than 70, so he passes. Sue passes, and then when you get down to Frank, he neither passed the final, and his highest score was only 68, so he failed the class. The last column, we utilize an if-else statement. That allows us to evaluate multiple expressions and then return the value for the first true expression. So in this case, we're assigning a letter grade. So we utilize the function equals ifs, open parentheses. So if the values in column E are greater than 90, the student gets an A. If the values are greater than 80, the student gets a B. If the values are greater than 70, the student gets a C. And if the values are less than 70, the student gets an F. And so if we look at the resulting values in column G in the upper left-hand spreadsheet, you can see that the students get assigned a letter grade that corresponds to their highest score shown in E. So the only student that fails again is Frank. He gets a 68. That's less than 70, and so he fails. We use statistical functions to summarize values in spreadsheets. We can either aggregate the values for a selection of cells or a column. That's pretty straightforward. You're just selecting those cells or column and then utilizing summary statistics to find, for example, what the sum of all the values are, what the average, the min max, or the count. Sometimes, though, you want to do it for the entire source table and you don't want to do it individually utilizing the statistical functions to aggregate values. So you can use a pivot table to pivot the values, where you rearrange or pivot the values to calculate the summary statistics for a number of columns and rows. And in this case, you've got the source table and then you're using the pivot table function to create the pivot table. And so source text fields can be utilized as your rows, for example, in your pivot table. Source text date and time fields can be added as columns. And then lastly, your numeric fields are added as the values in the columns for each row. Let's take a look at statistical functions in spreadsheets. If you look at the screenshot in the upper right-hand corner, you can see that first and foremost, we're utilizing some basic statistical functions like the View Statistics drop-down button. That's in the lower right-hand corner of the Google Sheet window. And when you have a selected set of records or a column in your spreadsheet, it automatically tallies those summary statistics like sum, average, min, max, count. And so in this case, I've got column D selected, and so it shows me the sum in that drop-down box. In the button just to the right of that is the Explorer. It shows me those basic statistics, but it also shows me a lot more information that I might be interested in, including maybe like a bar chart that takes my data and visualizes it. I can use the Sigma button that is on the far right-hand side of the toolbar. That button includes basic statistical functions. And so if I click in a blank cell, for example, and then click on the Sigma button and select something like sum, then it's going to enter equal sum in my cell. And then I got to select the value range, hit enter, and then it will show me the sum of whatever that value range I've selected. Again, you would do this for an individual selection or selecting a column, but if you wanted to calculate statistics for a number of columns in a field, you'd use a pivot table. Pivot tables are really easy to create, a little harder to get your head wrapped around, but once you do, you'll be amazed at how powerful they are. To create a pivot table, you just select a cell in your source table, and then on the main menu, you go to Insert and select Pivot Table. And this creates a new tab with a blank table in which the pivot table editor is open on the right. And there you can see in the lower left-hand example, I've got the pivot table editor open, and then I'm selecting the columns from my source table to serve as my rows, columns, and values. So in this example, I've utilized as my rows the category field in my source table. That's column C. And then that shows up in my pivot table as the unique values that are all found in the column C, which is category. Then for each category, I want to see how I paid for that, what type of account I used. So for the columns, I'm utilizing column E, the account column in the source table, and then I'm pivoting that column to the columns in the pivot table. So now I've broken out the unique expenses for each category by the way that I've paid for them. Last, to populate the values for these categories, I'm utilizing the amount column from the source table and pivoting those to create the values for the target. So now I can see the values for each category, but I can also see it broken out by account. And notice I've got the show totals checkboxes checked, so I get grand totals for the total expenses for each category, but also the amount of money I'm expending for each account type as well. You can see how this could be really powerful. You can even subset or filter the data by selecting a column from your source and filtering your data by that. In this case, I've selected the date column, so I'm only seeing the expenses for a specified range of calendar dates. Lastly, spreadsheets can use geospatial functions to convert values to geographic locations, and we can do that, for example, by geocoding addresses or converting coordinates. Examples of geocoding addresses are converting an address description, like 201 Main Street, to actual coordinates that can be plotted on a map, or you can reverse geocode. You could take coordinates and reverse geocode them and turn them into an address description. In this example, I'm not only geocoding addresses, but I'm doing it with a custom function. Now, there are a lot of functions available in Google Sheets and also in Microsoft Excel, but if you cannot find the exact function you're looking for, you can often either go out on the internet and find a custom function, or you can write a script and create your own custom function. In this case, I want to geocode addresses. The function doesn't exist in Google Sheets, So on the main menu, I clicked on Extensions, Add-on, and Get Add-ons. And that takes me to the Google Workspace Marketplace where I searched for geocode and found this add-on geocode by Awesome Table. And so I went ahead and installed that. And then once that add-on is installed, it also often adds the custom functions behind the scenes. So you can access the functionality either through, for example, an interactive panel like the geocode panel that you see in the far upper right-hand corner in the example there, or it adds to your function library where you can type the equal sign and then go ahead and access that functionality in a traditional function or form. In this case, I'm using the geocoding panel. I've selected the address field and then enabled geocode by Awesome Table and identified the address column as address, and then went ahead and geocode 100 out of 100 addresses. And then once I'm done, I can view those on a map and see my tabular data with location descriptions like addresses in a geospatial format on a map. Now, one thing to note when you're utilizing these add-ons, they're often free for a limited number of records, but if you're going to do 100 or 1,000 or 10,000, you'll often have to enter a credit card and pay for that functionality. And that concludes the topic, transforming data. Now let's review the performance criteria. You should now be able to describe how data functions are used to transform data by taking a series of inputs, applying a function, or for example, a formula, and getting a series of outputs. Basically, the function explains the relationship between the outputs and the inputs. You should be able to differentiate between concatenate and parse text functions. Concatenate is when we take the values from multiple fields and combine them into a single field. And parse is when we break out the value that is in a single field into multiple fields. For example, like taking an address field, 201 Main Street, that is in a single field and breaking it out to the address number, the address name, and the address type. 201 Main and Street. You should be able to describe the order of operations for mathematical functions. Using the mnemonic, please excuse my dear Aunt Sally, we know that parentheses go first, exponents go second, and then we get multiplication and division go third in order from left to right, and then addition and subtraction from left to right. You should be able to explain how logical functions can test value expressions, how you can take an input, test it, and if it's true, you can assign it one value, and if it's false, you can assign it another value. And last, you view spreadsheets to transform data.